Last week, we told you all kinds of interesting things about cows, but not the sorts of things you learned as grade school kids. That was all too obvious and too well known. Instead, we told you about famous cows, cow genetics, and how, really, cows should be called cattle, but because it doesn't make grammatical or historical sense, we don't. Oh, and we met a friend from D&D called Aurochs. All well and good, but as you can imagine, there was a lot more information about the basic beef than we could fit into one convenient-sized episode for you to consume. In fact, where we wanted to start was so far down the line of all things mooing that we kept having to back up further and further until eventually, what we had on our hands wasn't just one episode. Or two. Or even three. All said and done, it's going to be a whole series of 4 related episodes, all on things cowy. Which is good. It saves us a lot of time and effort on the front end trying to decide what to talk about each week. That's a whole month of episodes already planned out. Easy peasy. For instance, the next logical step in our discussion is to talk about milk. Why? Because milk is going to lead us, eventually, to what we wanted to talk about initially before we had to back this whole thing up to cows and their history. And believe us, a historically backed up cow is not to be trifled with. Which is why we're going to start with pigeons. You see, even though the official Merriam-Webster definition of milk is a fluid secreted by the mammary glands of females for the nourishment of their young, and even though we are taught in school that mammary glands and therefore milk are the exclusive province of mammals, that ain't necessarily so. Part of the problem is that we use the word milk for a number of things which are very similar and perform similar functions to actual mammal milk. In fact, to help distinguish milk produced by mammals from all the other sorts of milks out there, including so-called alternative milks, there is a specific term for it: true milk. In the case of the pigeons, what they produce is called pigeon milk or crop milk, and it's made not by mammary glands, which pigeons do not have, but by the crop, which most birds do have. A crop is a small sac in a bird's esophagus in which they store seeds and other food prior to digestion. Possibly so they can pick up lots of bits of food in a hurry and then get away before the neighborhood cat finds them. A few days before the pigeon's eggs hatch, both male and female birds will begin producing crop milk. And if you're picturing your typical glass of milk, well, perish the thought. Crop milk is much more like cottage cheese in consistency. It forms as fat and protein-rich cells on the lining of the crop. These cells then detach themselves and are regurgitated to the pigeon squabs. The amount of protein and fat in crop milk is much higher than even that of the cow. But like true milk, it also contains antioxidants, immunity-enhancing components, and antibodies the young pigeon needs for survival. For the first week or so, it is a squab's only food. And over the course of the next few days, the young birds are gradually introduced to more regular food in the mix until they are fully weaned by the end of the second week. But it's not just pigeons. Flamingos and emperor penguins do a version of this too. Flamingos because the apparatus needed by flamingo chicks to filter feed properly takes about 2 months to fully develop. And emperor penguins because the male tends to their single egg for 2 months straight until it hatches, while the female is off feeding. If she takes longer than usual to return, the male can temporarily produce crop milk to feed the by then hatched chick. And it doesn't end there. The discus fish, both sexes, produces a mucus body coating their young feed on that is rich in protein and antibodies. A pseudoscorpion, which is tiny and, except for lack of a tail, looks very much like scorpions, produce a milk for their young from their ovaries. And the Pacific beetle cockroach, which hatches its young internally in a brood sac, produces a milk from the cells of the brood sac that helps the young quickly put on weight, making them more robust and ready to take on the world when they are eventually born. Welcome to the fascinating world of milk. This is GM Word of the Week, and I'm Fiddleback. Mankind has a sort of love-hate relationship with milk. On the one hand, milk, as we've been told, does a body good. On the other, lactose intolerance is nobody's friend. As newborn human babies, we start out with some pretty severe disadvantages in life. We're incapable of almost everything, including the ability to defend ourselves from disease. What we need is an immediate booster shot of all the good stuff we need for fighting off illness, as well as the energy and raw material to power what is going to be a rapid sequence of growth milestones that our parents will, these days, post up on Instagram immediately, rather than storing them up in a scrapbook to show our dates and embarrass us with in our teenage years. For all this and more, we need milk, but not just any milk. A special kind of milk called colostrum. Mammals produce colostrum as soon as a baby is ready to be born, and it's the first kind of milk the mother will produce. It's high in protein and antibodies, and acts as a laxative to help baby with the first poo, which is essential because there's a lot of stuff stored in baby's first poo that baby doesn't want or need anymore, including a waste product called bilirubin, which results from red blood cells dying as the baby's body reduces its blood volume so it has just enough for itself. Too much bilirubin, and you have a yellow baby thanks to jaundice. Colostrum is full of lymphocytes, white blood cells needed to attack and fight invading diseases and illness, various other constituents of the innate immune system, bits that control how the immune system works and prevent it from running wild, and a whole host of other factors that mean wee bitty baby is going to someday grow up to be an annoying teenager who the parents will take great pleasure in embarrassing. And it does all this in a concentrated, low-volume way that means baby can make use of it in its still developing digestive system. Colostrum really does do a body good. In humans, it takes anywhere from 2 to 5 days for the switch from colostrum to true milk to occur. By then, protein and fat levels will have reduced, and the infant will be ready to digest the various components properly. For roughly the next 6 months, this is all baby should get. After that, other foods are gradually introduced, and, in general, 2 years down the road or so, baby should be well on the way to a nursing-free diet. Those components, though, those can be tricky, especially our friend lactose. For the majority of human history, mother's milk was what you drank for about the first 2 years of your life, and then that was it. No more milk was available or wanted. Once you moved on to solid food, you pretty much stayed there, and once you could fend for yourself well enough to feed yourself, you didn't really look back at milk of any kind. It just wasn't needed. So early man developed with that in mind. A couple of years of milk drinking, and then you could move on to soda pop trees or whatever was available. Which means early man only needed to deal with lactose, or milk sugars, for a very brief time. Once past that period, the enzyme lactase needed to break down lactose into less complicated sugars like glucose and galactose wasn't needed anymore, and the body stopped producing it in such great quantities. In many cases, by the time someone had reached full adulthood, lactase production pretty much came to an end. After all, you weren't going to be encountering milk anymore, so why should the body waste energy and material producing a thing you no longer needed? And this was all well and good for many, many years. A friend of ours once said the following about this next moment. He really wanted to know who the guy was who was so desperate for something to drink that he looked at his friend, pointed at a cow, and said, "I'm going to drink whatever comes out of that next." That could have gone wrong in so many ways. Fortunately, though, he got it right, and suddenly something called a pastoral society was born. A pastoral society is typically a group of nomadic people whose life is centered on the care and feeding of herds or flocks. It's post-hunter-gatherer, but pre-agricultural, and it survived mostly by staying with a herd and making use of its products, leather, meat, and milk. And occasionally dung, but let's not go into that. Take care of the cow, and the cow will take care of you. With the advent of the pastoralists, milk consumption became more regular and lasted later into a person's life, which, for many, many people, became unfortunate. See, without the enzyme lactase in your small intestine, the complex lactose sugar won't break down into its simpler, more easily digestible forms, which means that unprocessed lactose goes straight into your lower intestine and gets to hang out with some very robust bacteria in your gut. These bacteria love lactose. They love it so much, in fact, that they set up shop down there in your lower intestine and cause a couple of things to happen that you'd rather keep out of polite society. Just like every college kid away from home for the first time, they start trying to ferment the sugar in hopes of producing something good to drink. And just like every college kid away from home for the first time, those bacteria, in the process of fermenting, produce a lot of unpleasant-smelling gases, notably hydrogen, carbon dioxide, and methane. And those gases have to go somewhere. Better out than in, as they say. But that's not all. Sugar is hygroscopic, meaning it really loves water and wants as much of it as it can get. Once it gets inside you and makes its way down into your intestines, it creates osmotic pressure. In other words, it pulls water from the rest of your body across the permeable membrane that is your intestine to where the lactose is fermenting. And extra water in your colon means only one thing. We'll give you a minute to work it out on your own. So, for early man and the pastoralists, this change in milk usage created a number of problems thanks to a natural lack of lactase to break down all the lactose that they were now taking in. It's quite likely many of them were ill whenever they had milk, which meant that they were less effective at surviving and required additional energy to survive, which they had to do by hunting and gathering, which they were really ill-suited to do given their decreased energy intake and increased output, shall we say, because of their lactose intolerance. Enter the hero of the piece, the people who, for whatever reason, managed to retain more of the lactase from their youth into their adult years. They had no problem processing the lactose and therefore didn't suffer the ill effects. That made them more effective, gave them greater access to resources, and meant they had extra energy to go about their lives. Evolutionarily speaking, they were more successful and so were able to pass on that trait to future generations. So, why aren't we all a species of lactose-tolerant people? Well, because that particular advantage wasn't necessary for everyone. Really, aside from a very few localized places, a pastoral way of life just wasn't something they could do or needed to do, because most places where milk could be produced were too hot to store milk on a regular basis without refrigeration and without turning it into something else first. By and large, taking milk and turning it into butter, cheese, yogurt, and so on reduces the amount of lactose significantly, meaning there wasn't as much pressure on people to not be lactose intolerant. It just wasn't needed to help them survive better. But more on those things later. In fact, even in places where milk was a regular thing, once agriculture became a big hit, there was much less milk drinking going on. For much of its history, milk was too easily spoiled to be a regular beverage, and many people just did without it, because what you needed in order to have milk that wasn't spoiled was an actual cow. Right there, about 10 feet away from you. Or a goat, we suppose. But the thing was, a cow in the front room is inconvenient, and so not many people had one. And really, you only gave milk to children anyway. Adults drank other things because, again, the vast majority of adults A, couldn't handle milk, and B, used it for other, more valuable things because those other things kept longer and were easier to move around. Most people just couldn't be bothered with milk. It went on this way for thousands of years. Sure, milk got used in the mythology of many ancient cultures. Hindu cosmology contains the ocean of milk where Vishnu and Lakshmi are said to recline. The Greeks had a story about the infant Heracles, rescued and nursed by the goddess Hera, who suckles so hard he causes Hera pain. As she jerks away from him, a stream of milk shoots out and creates the entire Milky Way, which is why it is called that. And why we call it a galaxy. Because the root gala in ancient Greek meant milk. Combine that with the word for wheel, kyklos, and you have galaxy. Even so, the Greeks were, as we've discussed elsewhere, a bit stuck on themselves. They'd use sheep and goat's milk to make cheese, sure, but only barbarians, see our barbarian episode, would actually drink milk. When the Cyclops takes a break from eating men, he drinks milk instead. That's how bad milk was, only barbarians and Cyclops drink it. As for the Romans, well, only farmers drank milk. And famously, so little milk was consumed in Japan that visiting Europeans were called butter stinkers by the Buddhists due to the ambient milky smell they seemed to emit. So, for much of milk's history among most of the people, it was pretty much ignored as a source of refreshment and nutrition. Outside of Great Britain and the portion of Europe centered near Britain, no one much cared for the stuff for a very long time, even if it was processed into something else. It just didn't take. It wasn't until the advent of colonialism and the spread of European and British rule that the consumption of milk and milk products began to become a regular part of most people's diets. When industrialization finally hit the world in the early to mid-19th century, one of its key advancements meant that milk consumption would really take off. With the coming of the railroads, it was now possible to not only increase the supply of milk being made, but also to increase the reach of its distribution. Milk didn't have to be produced in your own barn, which, with the move into cities caused by industrialization, people increasingly didn't have. Now, country-made milk could be on the city table in the morning. The milk trade finally began to grow, albeit slowly, towards the end of the 1850s, as people took more and more interest in having fresh, whole milk. Which meant that the article in the May 8, 1858 issue of Frank Leslie's illustrated newspaper was perfectly timed to do as much damage as possible to milk's image. A 5,000-word article pointed the finger at a bunch of Brooklyn and New York distilleries and accused them of poisoning children with their milk products. Called swill milk, it came from cows fed on the steaming leftover grains from the alcohol distillation process. These cows were kept in terrible conditions and often only lived a few months, during which time they produced a sickly blue milk which the distilleries would try to mask by adulterating the milk with anything from chalk to eggs to molasses and flour. Then they'd slap a pure country milk label on it and sell it to the public, which in turn would feed it to children. The illustrated newspaper would then go on, in later articles, to claim that 2/3 of all children's deaths in Brooklyn and New York could be tracked right back to swill milk, claiming 8,000 deaths in the previous year. And then the accusation spread. Not only New York, but Boston, Chicago, and San Francisco all had similar problems, and public outrage was such that many of the distilleries that provided the milk would end up shutting their doors forever. In 1908, President Theodore Roosevelt's Surgeon General released a 600-page report that laid the blame for most of the nation's childhood deaths squarely on the door of impure swill milk. Fortunately, the Surgeon General also knew exactly what to do about it, because 40 years earlier, France had already figured it out. France had a secret weapon in the war against germs in the mid-19th century. See, up to that point, the war against germs was a losing war, mostly because no one could agree on whether there was anything there to fight at all, and if there was something there, whether you could actually do anything to prevent it from being there. The prevailing theory of the day was something called spontaneous generation, and it was first stated by Aristotle. At which point, it became accepted scientific fact for the next 2,000 years or so. Basically, it goes like this. Some living things don't need seeds or eggs or parents. They just happen, coming into being from non-living matter. You can no more prevent that from happening than you can turn off the sun. Mice, for instance, just spring living from the mud. You can't do anything about it, that's just the way it is. Putting basil between two bricks and leaving them in the sunlight would cause scorpions. Rotting meat caused maggots, and irrationalism caused Twitter. That sort of thing. Then, in the late 1700s, along comes a radical new theory. Well, not entirely new, but certainly in the 1700s, germ theory begins to pick up steam. The germ theory of disease says that diseases don't just happen for no reason. They don't occur from nowhere. They are instead caused by things, little things that are very, very hard to see. Naturally, all the real scientists in the room laughed at this idea. Don't be preposterous, we're prepared to imagine them saying. There's no such thing as invisible little critters that cause disease. Clearly it all just happens, nothing you can do about it. Which is why it took so long for Louis Pasteur to get anywhere. His was an uphill battle. He hadn't done very well in school, but had still managed to pass enough science classes to finally conduct research. And he kept finding things out about how the world really worked that just made spontaneous generation look like a big joke. For instance, one of Pasteur's first really big discoveries is that alcohol doesn't just become alcohol all on its own. It wasn't decomposition, as had been thought, that made grape juice and other liquids turn into wines and beers, but rather the process of fermentation. That's right, Louis Pasteur discovered it was yeast and fermentation that made alcohol alcohol, and that yeast, much like bacteria in your gut, really like sugar. After that, he sets about disproving spontaneous generation, showing that boiled liquids in sterilized and sealed containers wouldn't spoil and nothing grew in them. So it couldn't be the case that fungus and molds and other nasty things just happened no matter what you did. Air and contamination had to be able to get to the liquid in order for it to go bad. And because of that, in 1865, pasteurization became a thing. First with wine, which is what he was doing the initial boiled liquid experiments with, and then for milk. By heating a liquid such as milk to a relatively low temperature, but for a long period of time, pathogens are killed or inactivated, and shelf life is extended. Doing so prevents a whole host of diseases that used to be transmitted by unpasteurized whole milk, including tuberculosis, diphtheria, and scarlet fever, as well as killing the bacteria that cause salmonella, listeria, and staphylococcus. In the early 1900s, once the process was established in the United States, milk using pasteurization advertised it and touted the safety of their products. It was then that milk drinking, even among adults, really took off, and the milk industry today supplies nearly 93 million tons of milk a year in the USA alone. Worldwide, so much milk is produced today that no one actually knows what to do with it all. Nearly every milk-producing nation has far more than they actually need. But Louis Pasteur is responsible for a couple of other notable things as well. For one, he developed a vaccine for rabies. In 1885, under supervision of local doctors, because Pasteur was not a doctor himself, the first human rabies vaccination saved the life of 9-year-old Joseph Meister, for which Pasteur was hailed as a hero. But the second thing? Well, Pasteur also did work on anthrax in cattle, which led to the thing we just mentioned, vaccines, which Pasteur called vaccines in honor of a man named Edward Jenner, who developed a cure for smallpox using a weakened form of the related vaccinia virus, also known as cowpox. Thanks for listening to this episode of GM Word of the Week. If you're new here and this is your first episode, welcome. Thanks for checking us out. We do neat things with words, particularly words that tabletop role-playing game players might encounter in the course of their games. If you enjoyed this, don't forget to subscribe. Even with 235 episodes under our belt, we haven't finished yet. We know, who knew there were so many words? Nate B. jumped in with a very kind review this last week, for which we are truly grateful. If you find us in your podcatcher of choice and there's a way to rate or review the show, we certainly would appreciate it if you did so. It's an easy way to show your support, and it helps other folks find us as well. Supporting us on Patreon is also extremely helpful. Not only does it keep the show going in a general sort of way, it also helps us do cool things like gain access to research papers when the need arises, so we can read up on recent studies about milk production, for instance. If you'd like to help out, head over to gmwordoftheweek.com and click the yellow banner at the top. This episode was researched, written, and produced by Brian Milk Mustache Casey. Music for this episode was selected from the vast collection of Blue Dot Sessions. I won't eat any cereal that doesn't turn the milk purple.